So you have tangent of yellowish, reddish, orange, right? What's the derivative of tangent of something? So you have to look in your formulas. What's the derivative of tangent of x? Secant squared x. So you have secant squared of, not x though here, what? Purplish, orangish, reddish, right? And then you go inside tangent. You've done the tangent now. What's the derivative of what's inside tangent? Just 2x plus 1. I don't know why I put 2x plus 1. It's just 2x. Thank you. So what should I fill in with the purple here? What goes here? No, we already took derivative. Tangent, x squared plus 1. And then what was the red? Square plus 1. Man, you can't see that very well. I'm just going to write it below. 3 tangent x squared plus 1 squared times secant squared x squared plus 1 times 2x. Why did we? Where? Oh, okay. Because the derivative of the last thing happening was the tangent was being cubed, right? So derivative of something cubed is 3 times that something squared. Now, I think because I have done this so many times on a board, being able to be up there, and these colors are kind of funky, I think I'll actually get up on the board for once. I'll go up there and all that. Okay, so what if we have square root sine of say x plus x. I'm trying to do this with the shortcut, okay? I can make a table and do all that, but the shortest way. So I like this a little better in the colors because I can come here and put my arm over things. What's the last thing happening? Square root, right? So I ask myself, what's the derivative, right? What is the derivative of the square root of something? I don't know. 1 over 2 square root of my arm, right? Whatever that crap is, right? So I have 1 over 2 square root of, now you don't want to put x here, right? The derivative of the square root of x is 1 over 2 root x. But the derivative of the square root of junk is 1 over 2 square root of junk, right? So here's my, what? Junk is sine x plus x cubed. So I have finished looking at the square root. Okay? So the next step in chain rules say times, and I forget the square root's there anymore. And I say, all right, what's the last thing happening now? Sine. What's the derivative of sine of my hand? So cosine of my hand, right? So times cosine of my hand was x plus x cubed, right? Now I'm done with sine. So I go into the next one. I say times the derivative of what's there. 1 plus 3x squared. That's what you need to get to. I mean, the other way to have done this problem is to have done the table, right? So you go, look at this, don't write on these boards. The table would have been like y is equal to square root of u. U is equal to sine of v. V is equal to x plus x cubed. All this is just, if you can't get this straight in your head, you've got to act this back, fall back on. But this is where you want to be by the end of class, or by Wednesday. So what you'd really like to be here. But realistically, you know, it takes a little time. Chain rule can get a little tricky. It's the hardest rule of all, but it's the most important one. Okay, I'll do some more examples. All right. Here's one. Y is equal to 3 over cube root of 1 plus secant x. There are several ways to do this problem. Anyone have any ideas of how to approach it? Yes, you could do that. You could do quotient with chain here. Let's try it. Let's see how that would work. So you're noticing you have an F on top and a G on bottom, right? And therefore, we know that the derivative will just simply be f prime g minus g prime f all over g squared. And I say simply, I mean, that's the formula for it, if I can figure those out, right? Is f prime going to be a problem? What's derivative of f? 0. Okay, what about g prime? Yeah, that's going to be some work. So let's try g. Let's just write down what g is over here. G is the cube root of 1 plus secant x, right? That's what g is. I need to know what g prime is. That's what type of rule happening here? Is that product, quotient, chain? What is this? It's chain. It's function inside of a function, right? So what's the last thing happening there? The cube root, right? Well, do you know what the derivative of the cube root of something is? I know that you know what the derivative of the square root is. But what about cube root? So maybe I'll rewrite this to help. What is cube root the same as? Raising to what power? 1/3. So take your 1/3 out. It's like a power rule. 1/3 comes out in front. The junk to what power? Negative 2/3. So what I'm doing is I'm working off of this one in the yellow instead. Because I don't have just a basic formula for cube root. Square root we're all supposed to know, but cube root's a little more involved. So cube root I rewrote as all of that to the 1/3, and then I said, hey, look, the last thing happening there is the 1/3 power. So when I take derivative, 1/3 comes out, 1/3 all the junk to the negative 2/3. Now times what? Times we've done the 1/3, right? Times derivative of what's in here. What's the derivative of 1 plus something? Well, that's just each one, right? Derivative of 1 is 0. Plus, what's derivative of secant x? Secant x, tangent x. Oh, not sure what just happened. There we go. Secant x, tangent x. I'm out of room there. Am I done with chain rule there? I started with the 1/3. I took care of that, right? Then
after that, I multiplied times the derivative of what was inside, and that's right here. But I've done it because I did the derivative of 1 plus secant x all at one time. Because there were two terms, right? I did them each individually. So I've already taken derivative of secant. So I'm done. I have g prime. So now I should be able to come back here and rewrite everything. F prime we said was 0 times g, which is the cube root of all this crap right here, minus my g prime is just a mess. 1/3 1 plus